Hello everyone, welcome to my talk. The title of my talk is Distance Matrix of Enhanced Power Graph. This is a joint work with Anita and Hiranya. We all work at IISc Bangalore. I will start with some graph theoretic concept. So this is a general example of a graph. The numbers 1, 2, 3, 4, 5 are representing vertices of the graph and the black lines are representing edges. Let's construct a matrix out of this graph whose rows and columns are indexed by the vertices of the graph. I'll place 0 at the diagonal of this matrix. Let's look at the 1 to th entry of this matrix. Since there is an edge between the vertices 1 and 2 in the graph, I'll be placing a 1 here. If I look at the 1, 3 entry of this matrix, since there is no edge between the vertices 1 and 3 in the graph, I'll be placing a 0 here. Respectively, we can fill all other entries in the matrix, and this is known as adjacency matrix of the graph. Formally speaking, if Aij denotes the number 1, when there is an edge between I and j and 0 otherwise, then the matrix A with its ijth entry as Aij is known as the adjacency matrix of the graph. Another definition, suppose the vertex set is written as the union of some sets where each of the sets are non-empty and they are mutually disjoint. Then this represents a partition of the vertex set. Given a partition, if I choose any two vertices in a particular set and those happen to have the same number of neighbors in any other set, along with if I choose any two vertices in a particular set and they also have same number of neighbors inside that same set, then such a partition is called an equitable partition. Formally speaking, a partition is equitable if number of neighbors of u and v are same in any of the set vj. Denoting this unique number by Tij, if we define the matrix T whose ijth entry is Tij, it is called the quiescent matrix. One more definition, given a graph gamma, let's replace each of its vertices by a graph. Because there is a edge between the graphs K2 and K3, I'll be joining each vertex of K2 with each vertex of K3. I'll be doing the same operation with all the vertices. The graph obtained now is called gamma join of the graphs and it is represented in the following manner. Hopefully last definition. So let's construct another matrix out of this graph whose rows and columns are indexed by vertices of the graph. Placing 0 at the diagonal, let's look at the 1 to th entry of this matrix. To go from the vertex 1 to 2, I need to use minimum of 1 edge. That's why I'll be placing a 1 here. If I look at the 1, 3 entry, to go from vertex 1 to vertex 3, I need to use minimum of 2 edges. Therefore, I'll be placing a 2 here. In a similar manner, I can fill the all other entries of the matrix and this is known as distance matrix. Formally speaking, if Dij denotes the length of the shortest path between the vertices I and j, which is also known as their classical distance, if Dii is 0, then the matrix D with its ijth entry as Dij is known as the distance matrix. Let's see the graph related to groups. So given the group of integers modulo 4, let's construct a graph whose vertices are technically the elements of the group. Now, about the edge placement here, because I can write 2 as sum of 1 2 times, I'll be placing an edge between 1 and 2. In a similar manner, since I can obtain 3 by adding 1 some number of times, I'll be placing the edge between 1 and 3. Similarly, we can place all other edges. So what we have done here is, we have added an edge between vertices A and B if in the group B can be obtained from A or A can be obtained from B. Formally speaking, what we have done here is, if we have given a group G with group operation dot, then A and B are adjacent in the graph if either A is a power of B or B is a power of A. Such a graph is known as power graph. In this work, we have considered finite groups. Now, instead of A being power of B or B being power of A, if we replace this condition by A and B being powers of some other element, then we will obtain something called enhanced power graph. Our objective is to study the distance spectrum of enhanced power graph and adjacency and distance spectrum of power graphs of some groups. Last definition, called distance quotient matrix. So we define these numbers Tij superscript D in the following manner, and the matrix T with its ijth entry Tij superscript D is known as the distance quotient matrix. This was also defined in the book Spectra of Graphs, but we defined in a different way in our paper for our purpose. In this work, we consider the following abelian and the following non-abelian groups. So in our work, if we consider the unique non-abelian group of order PQ, then we find a joint representation of its enhanced power graph and the distance characteristic polynomial of its enhanced power graph. Here, enhanced and power graph are same. Next, we found same results. Joint representation of enhanced power graph of dihedral group, the distance characteristic polynomial of its enhanced power graph, and the distance characteristic polynomial of its power graph. For the dicyclic group, we first found the joint representation of its enhanced power graph, and using that, we found the characteristic polynomial of its distance matrix. Coming to our main result, if EPN denotes the elementary abelian group based on prime P, if G is direct sum of two such elementary abelian groups based on different primes P and Q, then first we gave a equitable partition for the power graph. Using that, we found out a joint representation of its power graph, where the underlying graph gamma is the graph given here. And using that, we found the characteristic polynomial of the adjacency matrix of the power graph of this group in terms of the matrix T1, which is the quotient matrix corresponding to the equitable partition, and this is a 4 cross 4 matrix. Its spectrum is very easy to find. Next, we found out the distance characteristic polynomial of the power graph of this same group using the distance quotient matrix based on the equitable partition V1, V2, V3, V4. We also proved that this same partition is going to be an equitable partition for the enhanced power graph, which led us to conclude a joint representation of its enhanced power graph in terms of graph gamma prime, where gamma prime is the graph given here. Using that, we first found out the adjacency, this characteristic polynomial of the enhanced power graph of this group, and later we found out the distance characteristic polynomial of its enhanced power graph as well. In our last result, we found similar results for the distance matrix of the enhanced power graph of the group EPN direct sum Zm. These are some references which are used in our work. So starting first two references introduce the beginning of the concept of power and enhanced power graph, and the later are focused on some application point of view. Thank you for listening.